Welcome back to the 6th chapter on multibody dynamics using Altair HyperWorks MotionView-MotionSolve. This chapter covers only the theoretical concepts on the MotionView-MotionSolve process overview. I thought it is important to include this chapter since I need you to understand the entire process that is involved in building a MBD model in MotionView and not just the graphical user interface, so that you will be confident in building your own MBD models by the end of this course. This is a flowchart that explains the process overview of MotionView-MotionSolve. MotionView is a preprocessor where the model building is done. You can either import an existing model in the .mdl format or save the MotionView model file in the .mdl format. After the simulation is complete and you have the results, you can either choose to save the model along with the result files in a session file which has an extension of .mvw. Similarly, a session file can also be imported into the MotionView graphical user interface. After the model is built, the next step is to save the model. You need to save the model before running the simulation. When you save the model gets saved in the .xml format, which is recognized by the MotionSolve solver. Once the analysis is complete by running the MotionSolve in the background, the files such as MRF, ABF, PLT, etc. for plotting and .h3D for animation are created to post-process the results using Altair's post-processing software for plotting, which is the HyperGraph, and animation is done using HyperView. There is also another stream to the process. Once the model is built in MotionView, the model can be exported and run using other solvers such as Adams, and the results can be further post-processed using Altair's post-processing software HyperView HyperGraph. This is a very convenient provision in MotionView. This is basically the process overview of MotionView-MotionSolve. Now, I will continue to explain regarding the MotionView model, that is, the .mdl format. So, MDL stands for Model Definition Language. The MotionView model contains the information in the form of this language, which is required to describe a mechanical system. Complete model information is stored in the MDL format, and MDL is basically a ASCII programmable language. Now, let me highlight some of the benefits of using the model definition language. You can open and edit the model in any text editor easily. It is very easy for model debugging. It also has the capability to build modular and reusable models. It is very easy to create a parametric relation between the entities in the model. In this slide, I will highlight some key points regarding the syntax of MDL format. All the models need to begin with a begin MDL open and close synthesis, and they need to end with the end MDL open and close synthesis statement. The syntax of the MDL statement is an asterisk, followed by a valid statement with its arguments defined. Statements without a leading asterisk are considered as comments. Example: I will be opening the simple pendulum.mdl file in a text editor, and I'll be reviewing the model for a body, joint, and a motion. So let's do that. I will open the model file. So we have the simple pendulum.mdl file here. So we have the simple pendulum.mdl file here. So I'll right click on this and I'll say edit with Notepad++. So you can easily open it in any text editor. So I'm using Notepad++ here, and you can see the various things that I already explained. So it always begins with an asterisk and begin MDL statement, and then all the standard statements, it always starts with an asterisk sign. So here we have the information about the body. So we created a free body, so that's given here, and also a point, and we call it point 0, And we also have two other points, point 1 and point 2 in this MDL file. And we also have a graphic which is a cylinder, which is basically representing the free body. And the other details of the cylinder is given here, or the other details of the graphic, for example, the radius of the graphic, everything is understood in this statement. So, and we've set the body inertia, and also these are the location of the points, and this is the initial condition of the body. So we had given the initial condition in the z direction to be 1000. So that's what is given here. And the output, we're requesting the displacement of the free body. So that's what is mentioned here. And then we've created a revolute joint. We've also created a motion. And for the motion, the properties, we've defined it using an expression which is sine 2 pi times time. And you can see the other statements here, and also we've given a joint initial condition, that is the rotation with 10 radians per second. So this is the entire model information that is stored, and the ending of this particular code, it ends with an asterisk and end MDL open and close parenthesis. So this is your whole model file that is stored in the background in the .mdl format, and it can be easily opened in any text editor, and it's very easy to understand. As you saw, I just quickly went through the entire script, and it was pretty simple to understand what is being written in the background when you create entities in the graphical user interface, right? Okay, now let's get back to the presentation. So here I'm going to explain about the MotionSolve input file. So as I mentioned in the second slide, once the model building is complete, we need to save the model, which gets saved automatically in the .xml format, which is the only format recognized by the MotionSolve. All the model data is contained in the MotionSolve.xml file except the flex body information, which is stored in the .h3d file. The input file contains both the model and the simulation command. Here is an example of how the data is stored in the .xml file. If we consider, for example, the rigid body that we created, it has the information on the ID, label, center of mass, inertia marker, the local part reference frame ID and its mass, and the inertia about the x-axis, y-axis and the z-axis. So this is basically the inertia about the diagonal matrix. So we have the values here. So this information gets saved in the .xml file. Now let me briefly explain regarding the H3D files. So there are three types of H3D files. They are the graphic H3D file, flex body H3D file and the result H3D file. It is very crucial to understand the differences between the three types. Graphic H3D. So it's created by either the CAD import utility or by using HyperMesh. It does not contain any result information, and generally it is used to represent parts with realistic geometry. It is useful for visualization, but it cannot be animated in HyperView. Moving on to the next type of H3D file, which is the flex body H3D file. So this is basically the modal representation of a finite element model, and this comes into picture when you are building a model using flexible bodies. So it is generated by using MotionView FlexPrep utility or by using the HyperMesh OptiStruct interface. So the modes and the displacement, stress, strain, contours can be post-processed using HyperView. Now coming to the last type of the H3D file, which is the result H3D file. So this stores the result from the MotionSolve and can be post-processed using HyperView. In the present and the next two following slides, I'll be explaining regarding the run option that you can see in the toolbar, which is used for running the simulations after building the models. So let me go to the graphical user interface. So this is the run option that you see on the client specific toolbar. The run panel basically allows you to edit the solver parameters. You can also change the type of simulation and also the simulation parameters such as the print interval and also the simulation time in the run panel. We can also control the type of result files and also their contents by changing the simulation settings and the output options in the run panel. So you can find the simulation settings and the output options in the same run panel. So you can also adjust your other parameters by clicking on these options, and then the particular dialog box appears and you can play around with the various parameters which are present in these particular dialog boxes. So I'll be illustrating this in detail when we go to the exercises. So this brings us to the end of chapter 6, and as I mentioned here, we do not have any demo exercise for chapter 6. It is just a theory. It is just a chapter which was based on the theoretical concepts. I hope now you've got a brief understanding of what happens in the background when you run a simulation in MotionView. Thank you.